Dear learners, welcome to my session on knowing advancement in science and teaching science. My name is Russell D'Souza and I come from Nirmala Institute of Education, a College of Teacher Education in Goa. So let us look at the structure. There are three parts to it. One is advancement in science, the second one is advancement in science teaching, and the third is role of a teacher. Let's look at advancement in science. There is a quote here for you by Isaac Asimov. It says the saddest aspect of life right now is that science gathers knowledge faster than society gathers wisdom. And so, dear students, learners, science has advanced beyond our imagination. Right here, if you see, this is a Google imagery of a NiOS right here in Noida. And we believe that Google Earth images are real-time images. In fact, they are not. They are near real-time images. So, making use of facilities like Google Earth, we can zoom in, we can pan the camera, just see whichever place we want to see. You do not need to go to that place. You can view it, you can print it. We can make use of historical imagery to know what a place looked like, and it has evolved over a period of time from past to present. And then right down there in the graphic, what do you see? You will see an embryo, the human embryo. And what is so very striking and surprising is that at that level, the genes can be edited. A step further, you see the genes in the adult human body being edited, the genome being edited. See the marvel of science, how far science has taken us. Look at this. This is an invention that grabbed the attention of the whole world in 2004 when Adidas came up with the shoes. So the Adidas One shoes has a built-in microprocessor that could think for itself, deciding on what kind of support the wearer needs when the wearer is walking or running or sprinting. If you look at this image, it shows you fish in water. And what happens when carbon dioxide dissolves in water is that we get carbonic acid. And fish make use of their olfactory sense to gather information about the surroundings. And when I say surroundings, it means to find food for themselves, a safe habitat, to avoid predators, to recognize each other and find suitable spawning grounds. And the increased levels of carbon dioxide in the water that gives carbonic acid actually affects or reduces the ability of the fish to sense smell, and therefore becomes very difficult for them to sustain. And so we have seen that science has advanced so much beyond our imagination and our scope. So if we are to match with science, then what sort of advancements do we need in the teaching of science? This is a question we need to ask ourselves, dear teachers. So, as teachers, are our science classrooms enabling learners to see the beauty and wonders of science? Is that happening? Are the students prepared to live and work in science and technology-rich environments of the 21st century? What is the interest and attitude of students towards science? All these are questions. Well, what matters is, are we facilitating science, or are we teaching science, or are we killing science? So, dear learners, you need to ask yourself this question, and this is a very pertinent question. It largely looks like we kill science because we teach science like any other subject. Some teachers, they teach science like they're reading a novel. Let us look at science of teaching science. What are the approaches to science teaching? Well, science, we know, has a unique nature, and therefore its teaching strategies must enable students to understand the content, its methods of inquiry, and the nature of science. Science cannot be equated to any other subject because every subject has its own unique way of dealing and it has its own unique content. Science cannot be rote learnt. For instance, we learn our multiplication tables. 2 multiplied by 3 gives you 6, and we say 3 3s are 9 and 4 3s are 12, and so on and so forth. You cannot be doing this with science. I'll give you a simple illustration. If you go to class 6 and you ask them what is a physical change, and the child would give you a definition that he has learnt by saying that a physical change is a change in which there is a change in either shape or size, color or state of an object. But if you ask him to cite illustrations, that is the place where he will stumble. Why? Because he has rote learned science. So if we rote learn science, then what happens is that we fail to know the nature of science, and we fail to appreciate the beauty of science that is all around us. Remember that science is all around us, and we live in a collection of disconnected facts and misconceptions. Very often, if our basics in science are not firm and strong, the information that we have is just isolated fragments which are disconnected, and many a times misconceptions too. So, how do we go about teaching science? Well, science inquiry places emphasis on the following. It looks at both process and content, thus helping students to develop an understanding of science content. So when I say process, my focus is on the doing part of science. How do we formulate a hypothesis? How do we observe? How do we record? How do we analyze? How do we tabulate? How do we interpret? How do we infer? So that's the process aspect of science. So inquiry teaches a child to become critical minded, to look deep beyond and within and find and observe. So inquiry looks at both process and content. The next one is relating content to students' experiences and prior knowledge. Remember that students who enter into our classrooms are not blank slates, but they are a powerhouse of information. All that we need to do is tap them. And the third one is encouraging students to be curious about the world around them. Now, I have a question for you, dear learners. You know, we like to wrap our food in that so-called foil, and many of us, you know, we call this silver foil just because it is silver. My dear learners, remember that just because something is shining and silvery doesn't mean to say it is silver. This is aluminium foil. So we tend to wrap all our food in aluminium foil. Now my question to you is, does aluminium burn? And I'm sure many of you at this point of time will be wondering, what sort of a question is this? I have seen a magnesium strip burning. So probably this will also burn. Well, I cannot burn right now, but what I have with me is a sample. And if you look very carefully, you will see this portion, which the whole thing is aluminium foil. You will see this portion which is intact, and you'll see this portion which was introduced into a flame. So if aluminium had to burn, then it should have burned completely and turned to ash, but it has not. Observe the piece very carefully. I have another piece. Look at these two pieces. What changes do you observe? Well, this is after putting aluminium, the strip of aluminium in the flame, and this is without putting in the flame. Now, my dear students, do we have the courage to know why this happens? Do we like to inquire as to why such thing happens? Well, the thing is this. If you look at the aluminium foil, now the aluminium foil is coated with wax, or if not wax, then it has a very, very thin laminate of plastic which is put on top of it. And so what happens is, when the aluminium foil is put into a flame, what burns is the plastic laminate or the wax, and what you get afterwards is just this. I hope this is learning for you, and I hope you will stimulate learners learners in your classroom like this. Well, let's proceed. So when we work with inquiry processes, We can use a variety of strategies that connect learning to the real world. Remember that I can teach learning in my classroom and I can go beyond my classroom. So, whether you do it in the classroom or outside the classroom, we have to connect learning to the real world because we are living in the real world. The second strategy that we can look at is making emotional connections. For example, coexistence between biotic and abiotic factors. We are biotic because we are living, but we have the abiotic factors around us. And which are they? You have factors like water, the air, the soil. And so, how do biotic and the abiotic factors they live in harmony? That makes an emotional connect for us. And that's how we learn to respect our environment. That's how we learn to respect the air that we breathe in. That's how we learn to respect the soil that grows crops for us. The next one is encourage processing of information. How does a child process information that is given to him? Remember that learning is not taking in what the teacher gives to the learner, but making a learner to understand what he is learning to the whole experience. And the last one is encouraging experimentation. So I will cite two examples for you so that you have a better understanding. Well, let's look at the first one, and that is how does a clinical thermometer work? Now, my dear learners, we teachers love to tell. We tell everything. But sometimes it's so sad that we do not know much about what we tell our students. And so comes in the whole concept of exposing students to a variety of experiences. This is the first-hand experiences, a real-world experience. This is a clinical thermometer. And if I look very carefully, it has a construction. So, you have the mercury bulb or the mercury reservoir at one end, and this reservoir or the bulb is connected by a mercury tube or a mercury thread, which is sealed at the other end, and this whole apparatus is enclosed in a solid glass casing. If you look very carefully, you will find a scale that is also marked on it. Now, what does the scale tell us? It tells us our body temperature. Now, many a times I have heard people telling, I have got fever and it is 100. What does 100 mean? Does it mean apples? Oranges? What does it mean? So here we see that we have failed in a job as teachers. So you will have two scales which are marked on it. One is the Celsius scale and the second is the Fahrenheit scale. And my dear learners, what is the body temperature of a healthy human body? Well, it's 37 degrees Celsius. So that's the average body temperature of a healthy body, all right? And so, as I said, the mercury reservoir is right here. It is filled with mercury. Now, I will say that the mercury reservoir has a very thin glass around it. So, why does it have a very thin glass? It should have been as thick as the remaining part of the body. Why is this thin? There's a reason behind it. The reason why the glass around the reservoir is thin is so that the heat of your body can penetrate this glass and hit the mercury so that the mercury rises into the mercury thread. That's the reason why the glass around the mercury bulb is very thin. All right? Now, teachers, you may say that this is a very delicate instrument and students will not be able to handle this. Trust me, I have worked around with this instrument with 20 thermometers in the class where 6 standard students were present for my lesson. It works wonders. Then let me take you to another example. This is about combustion, and we teachers love to stick to our textbooks. Whatever our textbook says is the truth for us. We do not like to give experiences beyond the textbook and even clarify what is there in the textbook to our students. So let us take another example, and this is how we can encourage experimentation. So we make use of a strategy in here known as the predict, observe and explain. So children make their predictions, they observe and they explain in relation to a phenomena. So let us have a look at an example. So it's about combustion. So how do we establish that oxygen supports combustion? We really do not know. So let us have a look at a video. Now the question before us is, which gas supports burning? So now this particular girl is telling us about the different components of the gases, which are different components of air, and she says that air is made up of different gases. For instance, nitrogen, oxygen, carbon dioxide and other gases. And the percentage of nitrogen in the atmosphere is approximately 78%. Of oxygen, it's about 21%, and carbon dioxide and other gases together constitute approximately 1%. So if I have a lighted candle, then which component or which gas supports burning? That's the question before us. And so here I have with me a glass jar, and there is a hole that is punctured to the glass jar in the middle. And what I do at this point of time is I light a candle, and this candle is put into this glass jar. Now learners, what would you expect to see or happen if I cover this glass jar? Now that's a prediction you are going to make. You may say the flame may extinguish or it may not extinguish. So what you see here is that the flame extinguishes. So why does the flame extinguish? That's the question before us. So that means there is some gas that is required for the candle to continue burning. So we have seen the demonstrations, and now let us look at the characteristics of these strategies. Now if you look at these strategies, they are all hands-on strategies and minds-on. Hands-on because the child is doing it, and minds-on because they are immersed in conducting that particular activity. It allows students to manipulate different apparatus and different objects. It engages the learner and also makes them reflect. They make use of the scientific method, and it develops higher order and critical thinking skills in students. So do you see that there's a shift from what the teacher does to a shift where learners have to learn by doing. So this is nothing but learning by doing. Let's look at another strategy, and this is known as concept mapping. So concept mapping is a teaching learning strategy that has been found to be very useful in enhancing learners' science achievement through meaningful understanding. So how does concept mapping help students? It helps students to brainstorm and to generate new ideas. It encourages students to discover new relationships and also to connect these relationships. It allows students to clearly communicate ideas, their thoughts and information visually. And it facilitates integration of new concepts or patterns with concepts or ideas that they already have. So when I look at mind maps, in simple words, it is a graphic organizer where everything is presented graphically with the central theme right in the middle and all associated concepts around it. For example, if you look at this concept map, it's about the clinical thermometer. And what are the things that you see around? You will see that the clinical thermometer is used to measure the body temperature. Then we also have the precautions to be taken care of when we make use of the clinical thermometer. Then the other part is the temperature range that is marked on the thermometer and the scales, and then the construction. And in the construction you will see that the thermometer is made up of the mercury bulb or the mercury reservoir. there is a mercury thread, and there is another small little band in the mercury thread which is known as the kink. So, if I look at the mercury thread inside, there will be a small little band. There is a small little band which is not so very visible, but if you look at it very carefully, it's somewhere here. So, this is known as the kink. So, what happens is when the mercury rises into the mercury thread, it does not drop down even if you hold the thermometer this way. So, the purpose of that particular kink is to keep the mercury standing at the level or position where it is standing. And so, if you want to drop the mercury down into the reservoir, you need to give it a jerk. So, 2 or 3 jerks, gentle jerks, drops the mercury down into the reservoir. So, what we see here is a concept map about the clinical thermometer. Now, there are other strategies also that we can make use of. For example, we have NROER, that is the National Repository of Open Educational Resources of NCERT, wherein you have a variety of material and science that is available for us. Now, OLabs is online labs, which is again prepared in India, and the material is available online for us. So, this can be utilized by students who are in class 9, 10, 11, 12, and this is virtual learning wherein you can conduct your experiments virtually. We also have YouTube and Khan Academy. So, in this way you see that there are a variety of resources that we as science teachers can make use of. We can use a variety of strategies. I have spoken today about a couple of strategies. For instance, I have looked at inquiry, and inquiry is a very important strategy that we as teachers can make use of in our classroom. The next one I have looked at is concept maps. I have given you an example of one concept map. So, in this way you can build many concept maps. Now, concept maps have to be built very, very carefully and systematically. They basically condense information. If a concept map is not constructed appropriately, then it's going to be difficult for a child to understand all the related and associated concepts. It also has to be very colorful. And I have looked at digital resources, and I spoke about 4 resources. I told you about NROER. You have to go online and make use of that resource. OLabs is again an online resource. YouTube and Khan Academy are again online resources. So, all the very best.